Everyone. Sorry, I think my internet just like went out for a second and it dropped everything. Um, yeah, sorry. I guess I don't know if anybody's come back, but let's see if I can get a link to this. See if we can find. Put it in my Discord and see. Okay. Ooh. See if anybody comes back after after the stream crashed. Okay, let's see. Wait a second. See if anybody comes back. Put it in the Discord. So yeah, I'm sorry about the crash. I don't know if like my internet company was like not wanting, for me to keep streaming, but I've got the image sharpened, so I'm gonna go and download this, and then we'll bring it into GIMP and we'll compare it with the original. So yeah, we go and download the process file, and we'll put it in the same folder as the other ones. Call it sharpened. Open it up. So yeah, I'm really sorry about the previous stream. Technical difficulties. I saw I saw what was happening. Like I kept I was dropping frames and dropping frames and dropping frames, and YouTube's like, if you don't start, if you don't restart your streaming software soon, we're going to close the stream out. And there's nothing really I could do. Like OBS was on, it was recording, it was even, I don't know what exactly was happening. I don't know if it was like my CPU was just, I don't think it was my CPU or anything. I think it's just the internet. So I checked the speed test, the speed test, and it's like the upload speeds were fine, but when the download speeds were fine, but the upload speeds were really slow. So I think for a minute there, like I wasn't able to like upload anything. It just wasn't working. But anyway, we've got it sharpened. I've downloaded the image. We'll put it back into GIMP, and we'll open it up. We'll open up the sharpened image as a new layer. And we find this sharpened one, and we'll see if we like it any better. Whew. Yeah, I hate it when the streams just die like that. Everybody was having such a good conversation too. Okay, so let's see. So we've got, here's the sharpened one. Let's turn it off and see. See, the stars are sharper. I can tell that much. I don't think it's quite aligned. Well, maybe it is aligned. I don't know. It's hard with AstroSharp because you never know like what it's gonna do. Like I think it's fine like that, honestly. Like, I think that's just what AstroSharp does. Stars are a little bit wonky. I need like a good field flattener for the scope. I just use a reducer. And so we get, I don't know, depends on the corner. I don't think my scope is well collimated either, which can be a problem. But so okay, so we've got an AstroSharp. I think it looks better. Like, it's a little bit sharper. The stars are a little bit tighter, which is good. Do we still have the halos? We still have those halos. So on a third, if I were going to do this a third time, I think I would try and process it in a way that we wouldn't get these weird halos everywhere. But what can we do? Also, like, AstroSharp didn't treat these big stars very well. Well, it kind of like made them less bright, which, like, I don't know if I would notice anyway if I didn't wasn't blinking back and forth. Like, these very saturated stars are no longer saturated, which is not, I mean, it's not bad. So let's go ahead and put an Astro Clean, and then with that, we'll call this iteration finished, I think, after we do Astro Clean. But yeah, I see a couple people are coming back. I don't know if, hopefully you were here for the previous stream. But yeah, my internet just, I don't know what happened. It just stopped uploading data to YouTube. Like, it would download fine, but it just stopped uploading data, and YouTube thought I had ended the stream, and so it kicked everybody off. And then I tried to start the stream up again, and it wouldn't do anything. So, okay, let's put this into Astro Clean, so we can clean up the background a little bit. And yeah, let's see what happens. So here it is. Yeah, Gremlins. Gremlins, yep, exactly. Never know what it is, but okay. So let's browse and open up the sharpened image this time. So this is the sharpened version. Oops. Open that, and then, oh no, I don't want the full image. No, I'm going to close this. Astro Lemons, yeah, exactly. Yep. Yeah, I'm going to restart AstroSharp again because I didn't want the full image. I don't want to have to reprocess that full image for like 5 minutes. Okay, so let's see, do the sharpen image, open that one up, and then we're going to change this to Astro Clean. We'll keep aggressiveness at 100% for now, and we'll see if we want to keep it like that. Yeah, Gremlins, no fun, no fun. Yeah, it's cleaner, definitely a lot cleaner. I think the question I was asking before it left was like, has anybody used Astro Clean first and then gone to AstroSharp? Like, has anybody tried that? It's kind of interesting way of doing it. I've had a couple people tell me that that's the way they've done it, and it works for them. And I've never really tried it that way. I'll maybe have to try it out one time and see what happens. Okay, let's see. I've not used either of them. Yeah, I think if you have, do you use Blur Exterminator and the other one, Noise Exterminator? I think those are, like, if I had those, I would use those over AstroSharp, and I'm the creator of AstroSharp, so but yeah, I have to take them for a spin. Yeah, I think AstroSharp's a good program for what it is. It's not as powerful as the X's, Blur Exterminator, Noise Exterminator, etc. But it's definitely better than some of the other things that I've used. Yeah, RC Astro tools. Yeah. I think it will screw up the PSF if Astro Clean first. That's what I think. I think it like would blur things to like whenever you denoise something, you're going to lose detail. And so I think when the people who told me that they used Astro Clean first and then Astro Sharp, it's like, okay, I cleaned up the noise, and then now it's not going to sharpen any of the noise, and it's going to give me back the detail. And I think I just have to experiment with it and see what like kind of works. I think Astro Clean is very aggressive though. So if you use it like 100% aggressiveness, you're going to get like it's just very aggressive. So we could try it at 100% aggressiveness, or we could move it down to something like 50 or 60%, which is something that I normally use as a default, or as not as default, but just as my personal preference. In terms of like RC Astro, they're like the X tools, Blur X, Star X, Noise X. Like, I really would like to keep improving Astro Sharp, and I think I know what I need to do. It's just like, do I have the will to do it? It's gonna take months to train like a new like model that can like be kind of comparable to RC Astro, and I don't Astro stuff, and I don't know if I have the processing power on my computer to do it. But it's something that I would like to try. Like the thing is, like if I the minute I start doing it, it's just going to cut down on anything else I can do. So if I like want to create a video about, I don't know, is astrophotography real, like which I'm kind of working on right now, or possibly a video about making custom Batinoff masks, like all of my processing power will be like dedicated to training a neural network, and I won't be able to do anything else in the computer. So it's kind of like I want to do it, but it's a little bit difficult. Okay, so we're at 60% noise reduction. Maybe even it's Astro Clean is just super aggressive. So let's try 25%. It is very aggressive. I think I don't notice too much of a difference here, so maybe something 40. Yeah. Yeah, they've like if I had RC Astro stuff with Pix Insight or whatever, like I'm not sure that I would like you're probably better off with those tools. Like I created Astro Sharp. Like I understand this, but like I think that for a lot of people, like Astro Sharp and Astro Cleaner will get you like 90% of what you want. Especially if you have really good SNR. So the more SNR you have, like just the better Astro Sharp works, and the better RC Astro tools work too, because like just SNR just is the thing. It's just it's the most important thing. Like everything else, like any other AI tools that are meant to like bring out detail or clean up your image, they work worse if you have less SNR. But yeah. Okay. So let's try 40%. I think that try 50% real quick. Let's see how much I like it. Yeah, let's go 50%. I think it's fine. We can always, if we don't like everything, we can always change the opacity and combine it with the sharpened image. And then we'll see. So let's see. Hopefully I won't be dropping any frames. I didn't think it was Astro Sharp running that like was messing things up, and it doesn't look like it is, but hopefully like my internet will keep working as this goes. but I have been trying to like from what I've learned making Astro Sharp and Astro Clean, I have I feel like I've learned a lot about, you know, just making neural networks that process images. And I think I can make a tool that can go like section by section through like various convolutional neural networks and just take out tracking errors and take out, you know, um, uh, like what's the word? Um, like coma and take out all this other stuff. But it just it's very difficult to train a model like that. Like it's just hard. Um, I just wouldn't have a clue where to start writing code for AI stuff. Yeah, it's it's gotten a lot easier. It's gotten a lot easier. Yeah. Says AstroChat says usually I use 0.55 denoise on noise exterminating even under 1 hour integration. So it's aggressive too. Yeah, yeah. I think I think making a denoiser is a lot easier than making it like a deconvolution tool. But even it's very difficult, I think. But like, so denoisers can be very aggressive and get rid of a lot of detail. So Dave, if you, I don't know if you have any coding experience, but like there are tons of stuff on the internet now. Like you can look up and it'll help you out. Like Keras, like I've used Keras a lot with R in conjunction with R. Keras was meant for like I guess Python or maybe a standalone language. I don't know exactly, but it's really kind of like democratized, I think, um, neural networks. So you can have all these different companies making neural networks do whatever they want to. All they have to do is have like a computer that's big enough to be able to like train it, like with enough GPU memory and stuff. Which my like I would say that like my GPU is a mid-range GPU from like about 4 years ago. So so I'm very limited in the types of models that I can actually create. Um, so like a convolution neural network, for example, you have like a what it does is you have like a you split the images into parts. So you have like a 256 by 256 square. Like that's what you might have, for example, with a the convolution neural network, like a 256 by 256 square. That's just a segment of the image, and then on that's the input for your neural network. And then what you have is a whole bunch of like convolution kernels, like with a kernel in GIMP or in Photoshop, you have like a kernel that sharpens your image, right? That does convolution or deconvolution on parts of the image to like make it sharper or blurrier. It's the exact same thing, except like with these convolution kernels in Photoshop, right? They're fixed. You know, they're fixed parameters. Like there's like a 3 by 3 kernel, and then you like each cell in that kernel has like a 1 or a 0 or like a 0.5 or like, and that determines how much sharpening or blurring happens. With a convolutional neural network, right? You let the the computer determine what those kernels should be. And instead of just having one kernel, you may have on the first layer of your network, you may have like 32 kernels. And then like what that does is it shrinks the image a little bit because when you deconvolve or when you convolve an image, when you convolve an image with a kernel, if you don't have any padding or anything, it's going to shrink the image a little bit. You take all those kernels, right? And you convolve it, and then that's the next layer. The layer after that is a whole bunch of more kernels, right? Like maybe 64 kernels, and you convolve all of those previous kernels. And so it's just like this iterative process that you get more and more kernels as you go down, but the images get smaller and smaller. And the input image for that layer gets smaller and smaller. And then you get to a point where you have like a whole bunch of just single pixels, and then you have to like reverse that process. So you can step up the one kernel images into another 256 by 256 image. I'm sorry if I'm boring you with all this. I don't know if this makes any sense, but all of that means that there are millions and millions of parameters. So you may have like 9 million parameters for that, or maybe even 20 million parameters, depending on how many kernels you have at each layer. And AstroSharp, for example, has like 10,000 parameters for like one of these models. Like altogether, there's probably like 270,000 parameters or something when you combine all the models together. But like for a single PSF model, there's maybe 10,000. And 10,000 is enough to like do a simple kind of like sharpening, smarter sharpening type of thing. But with a convolutional network, you're taking that a step higher, and you just need like more processing power. And so if I wanted to do 256 by 256, segment of an image and deconvolve that through some sort of convolutional neural network, I might not have enough GPU memory, or might run out halfway through because something happens. And so I might train it for like an hour and then suddenly it crashes. It's a lot more difficult. And the thing is, what I think needs to happen is need to be able to get the neural network to, one, be able to estimate like how the part of that image, whatever 256 by 256 part of the image, has been convolved in the first place. So like how it was been blurred, like how much tracking error there was and how much other stuff. And then you need to step it through different neural networks to like take out that tracking error and take out the like just the whatever the Moffat or the Gaussian blur is of the image. And so it's complicated. I know what I need to do, but it's just a matter of trying to do it, getting the willpower to like create the data set, like match the data sets with the inputs and outputs, and then do it right. Like I can automate most of it, but it's hard. It's different. It's hard. And I think, RC Astro has done quite a bit, quite a bit of work, and he's got better hardware than I do too. So let's see. You see this as a cleaned image. Yeah, sorry, I'm rambling on about stuff. And we'll bring it back into GIMP. We'll see how the cleaned one looks. Yeah, I can't, from this far out, I'm not sure I can tell. Let's zoom in. Yeah, I think it's cleaned up a bit. So if this is the original, this is the sharpened, and then this is the cleaned image. What I like about Astro Clean is like normally if you do like some noise reduction through some sort of Gaussian blur, sometimes like the stars can get a little bit blurry too, but it doesn't seem to blur the stars. It keeps them as they are, which is nice. It's nice. I like it. I like this image a lot better than this image. I think if I were going to do a third iteration, which I probably will do, I'll try and process a little bit differently so that I don't get these halos around the stars. And I think probably the best way to do that is just when we go into RGB compositing, we just add the luminance layer here. So if I can find that image, we add that one in, and then then we see if we can do background neutralization. Something like that. Oops. And then that way, when we stretch it, everything's together. But still, we get kind of weird things going on because of the gain settings. I'm pretty sure most of it's because of that. So, but I'll probably process this one more time at some point before I make it a final image. But I think it's a step up from this image, definitely. So, yep. I think that's about it for me tonight. I'm starting to get a little bit tired. It's late where I'm at. Rafa knows. If he was here, he would know. It's about 12:30 in the evening at night, so past midnight, and I've got some work to do tomorrow. So, I think I end it here. Thanks everybody for coming back. I'm sorry that the stream ended suddenly before, and whatever. But yeah, hopefully this helped. I'm glad. I'm always glad to talk to people who I'm processing images, and I like the company. So, great. Hope everybody has a good week, and I'll maybe stream sometime next year. Yeah, 7:20 a.m. too. yeah. So so you maybe a little bit tired there too. Thanks, Dave. Thanks, everybody. So hopefully be back next week with some more data. I'm taking some pictures of the Orion Nebula, and hopefully I can get some good data with that. I've already got about probably about 2 hours worth. So maybe do a geek stream one night showing the code level. Yeah, I was thinking of that. Yeah, it's noon now, Astrojet. So are you so Astrojet, you must be like, are you in Australia, New Zealand? Are you, is that where you're at? Yeah, code level. Yeah, I think I might do that one night. I can show sort of the code of AstroSharp and see how I'm doing it. I was thinking about doing a whole video on it, like a not a stream, more of a polished video on the code. But the problem is if I run the code, like the stream is going to crash. I don't like that. It just won't do it. It won't be able to, like, my GPU will probably just like scream at me and be like, no, I'm not going to stream and run this at the same time. And it would just crash all the time. But it might be interesting to go through the code and as a sort of at a high level and say, this is what this does and this is what this does. So, all right. With that, hopefully you guys enjoyed it, and thanks for stopping by and keeping me company. And I'll again hope if I get some more data, I'll have a stream next week on hopefully the Orion Nebula, maybe maybe something else too, a surprise. So yeah, high level code, that'd be fine. Yeah, I'll do that. Maybe if it's cloudy, I'm getting data. We can do that next week. So, yep. Thanks everybody. Talk to you later. Bye.